Goes up through the two bits of text. Don't do that. Don't do that in the assignment. If we printed that out, it might be we couldn't even read that is a 2 and a 7. And you soon get the big bar schedule guy stomping back into the office to say what's going on. Up there it's getting a bit close to the number 1 by the 17 as well. We generally do not put dimensions on a reinforcing drawing, so don't put dimensions on your drawing. This next one has got dimensions on it, and the student was marked down for that. Those dimensions, now how do we do this? Rotate clockwise, rotate clockwise, rotate clockwise a little bit. Yeah, they put dimensions over here. Generally, we don't put dimensions on anything with reinforcing in it. It's not so much on that one, but on this view here, putting dimensions on it is a no-no. Interestingly enough, there you've got a few notes. You may be able to use 1 or 2 of them on your own drawings. And obviously your cover is not 32 mils, it's, I remember it's either 40 or 50 I think. So there's a few notes to kick you off. There's also a lot of notes in my and here's another example of a quantity schedule with reinforcing bars. Now where this student lost marks was they didn't put any numbers on these pieces of the sketch for the reinforcing. You're supposed to put the numbers on there.
Like dimensions?
Yeah, as the dimension is as per my class example and as per the class exercise number 2. So you have to look through those and see where the dimension starts and finishes. Right? The other thing down here, when you finish the scale exercise today, you'll see that the student has not done this correctly either. The angle is, they've basically just gone with, they've written the angle and they've copied someone else's total weight. They haven't done all this, they've just gone, oh, what did you get, bro? I got 10.43, cool, I'll copy that down and I'll get full marks, all right? So you do need to, you don't have to show any calculations, but you do need to fill out the bar sheet, the steel chart properly, okay? Right. So we need the class example, and I need to download the model answer too, just so I don't get it wrong. We'll be reading in about a couple of seconds.
Find that draftsmen spend a lot of money on their mouse, being that that's their major tool of the trade?
I find that even myself ended up getting used during my working career, yeah. So it's a good idea to invest in something that won't do that. There's some pretty fancy mouses out there.
Yeah, my wheel at home seems to stick.
Yeah. I know as a student it's not so good because you can't afford these things, but we used to get someone visit the office and look at some alternative mice
Design.
mountains. Yeah.
There's some with you can buy them with a higher DPI, like 3200 DPIs. Those.
Yep, you can buy all sorts now. Yeah. Same with desk heights. I saw a desk which had the ability to raise everything up and down so you could work standing up.
It's really
And it does help sore backs and those sort of carry-ons. I never had back issues, but I've definitely got the OOS thing, and it's one of the awfulest things you can get because you boss tells you to do something and you're in pain, just trying to do it, takes you a while to go away. Therefore, as an engineer, you probably need to try and get work that involves outside work, inside work, and as well, and manage your time. Walk around the office or manage your breaks, I guess. So that's a whole new other side. So the class exercise today is this one here. And I showed you that briefly during the lecture, so we'll talk about that in a minute. I'm just going to open up the where has that gone? Someone's going to help me here, so I'll figure it out. Just we see this stuff.
所以最后我们是教啥呀？我们都是教这个呀，还是教这个？
都教，写上。
都教。哦。画毛名吗？
画鸡毛。
So what's going to start happening with assignment 3 and 4 is that you guys are probably going to push it to the back of your list of things to do, because it doesn't have to be done until the handed into the middle week of the school holidays. But the problem, there's two problems that I foresee with that. Not quite sure what's going on here. Close. Try that, and try that. Okay. And grab that, and that over here. Right. Assignment 4 is, there's not much time for assignment 4 after you come back, because there's a week of the break to do it in, and then there's only a couple of weeks when you come back, and also there's a structural test as well. And I think a couple of those things coincide with other tests that you've got on. So the whole pressure thing comes on if you don't make a start on assignment 3. I'm only trying to be helpful. You do it in your own time. I'm not here to organise your time for you. So what I'm trying to say is, for example, as far as doing the quantities go, you could actually draw those elevations up. It's almost a copy of what I've got there. So you can actually draw them up and then work out the lengths of all the timber, get the quantities right, and you've already made a good start on assignment 4. The bottom elevation of the concrete, you could start drawing that up too, and work out what things look like in a section view. And it's not part of assignment 3, please do not hand that in to me in assignment 3, any viewports at all, but it's more progress towards doing assignment 4. I won't be probably demonstrating the 3D until the first week back after the break at this stage. We'll see, I'll see how that works out. But that's only with 5 marks of all the assignments that you've got to do. See, what actually happens with my work is students leave the assignment 1 to the last minute, and then they've only got 2 weeks to do assignment 2, and most of your assignment 2 marks have gone like that. All right, after some very good marks in assignment So you try not to let that happen with assignment 3, especially if you're struggling with assignment 3. You should be starting as early as possible. Past students aren't allowed to tell you how to do the schedule, but they can show you and give you some tips on how to start doing the drawing. Okay, so now's the time. The labs are the time to do it. You don't get another opportunity. So there's one more week, and then you're on your own in terms of one-on-one with everything. Okay. As far as this goes, this is actually going to be in the test. So there'll be, what I do in the test is I change this around. So this member here might be a channel of a different size. This one here might be a different size beam, different size angle, and different size plates. The length might be different, and some of those figures up there might be different. So you need to know the principle of how we work this out. It's not too bad. Most of the students last night walked away going, oh, it's not too bad. I think I can handle that in the test. But it will be in the test. With this, every student will have to do at least 2, maybe 3 questions from this particular exercise in the test. So it's well worthwhile putting it in your memory banks. Also, when we finish this schedule, you'll have a very good idea of how to do the assignment. It's only worth 1.5 to 2 marks in the assignment. Can't remember what it is, but around that area. But it's still marks you can get in the bank quite easily at the same time as learn how to do this. So last night we started off, and I'm about to start off now, and I said I will start with the beam. 533 by 210 by 122 UV means universal beam. And I said, how do we call that up? And everyone went, I don't know, because I don't even know that you said anything in the lecture. Oh, that's right, you're offered half a mark in the lecture for why you've got the old call-ups in there and no one answered it. So we call it up 533 UB, and then if you look back on your notes, you'll see it's by the weight per metre, which is the last number over here on the old way we used to call it up. So it's 122. There is only one of them. They run the full length of the girder. Up the top there you'll see schedule the members and calculate the weight of a 6 metre girder. So it's 6 metres long. There's only one, and it's 6 metres long. Don't worry about the width. The mass per metre. Last night I said to everybody, well, what's the mass per metre? After I'd already said that 122 was the mass per metre. 122. That times that times that gives us a grand total of 732. The next member that we did last night was the channel at the top, and we call this up by the, oh that's right, last night I offered half a mark for anyone that could tell me what that number is. How we call this up?
381
So, hold on, we had someone talk there. 381, yeah.
CH.
CH, 381. CH, yeah.
55.
55. Wrong. Anyone else? 381 CH 102. That's wrong too. Your moment to shine. It's your moment to shine. You were the one who couldn't get it last time. was so close.
381C 555.
No,
No H.
no. So we talked about the two channels. One was parallel
Oh yeah.
and one was
Tapered.
tapered. Yes, tapered, that's right. So what we call that up as is 381 T tapered flange channel, and whoever said 55, you said 55 is correct as well. Now if it had been that one, it would have been a and the P stands for yes. Okay, there's one of these. They're 6 meters long because it sits on top of the beam, runs the whole way through. That is a terrible ringtone. Made it silenter. Mass per meter, 55, right?
Oh, is that what the 55 said?
Yep. And 330 total, correct.
Oh, when you say mass per meter,
Well,
what are we talking about? 550 grams?
and not grams, you got the wrong terminology. You're talking like a survey when you say that. Kilograms. Yeah.
55 kg per meter.
Yeah. So these are fairly solid beams, right? Yeah.
Yeah, no,
So it's interesting because you should say that. We used to have the surveyors, we used to make them because they were a smaller group in the past, we used to make them do this course, so they had to do the structures. And it was like trying to give a dog a bath when the dog didn't like water,
Yeah.
screaming and yelling and I don't want to do structures, it's awful, blah, blah, blah. Turned out they weren't too bad at it, but the one thing that they weren't so good at, you guys have to do mechanics or fundamentals or whatever it's called, and then structures. Well, they don't do that. So when it came to this exercise, they used to just put everything in millimeters, and I used to get an answer over here would be 3,330,000 something or other millimeters, and then they would call it, instead of kilograms, they call it grams, just like you did then. So you get sort of like 3 million grams as an answer. Now you guys know from your studies that everything is in kilograms when you're working things out, because especially structures, you know, working out newtons and stuff. So to do kilograms, you've got to have everything in meters. So this chart here is always in meters, and you'll see that in a minute when we start doing our angles. It is hard to get your head around. They're very heavy. Beams are heavy.
When you say 381 there, that's the width of the channel, the depth.
The width,
Yeah.
or the depth, depending on which way. The long length. Yeah. And that other length that's there is the smaller length of the channel, which is 102. Yeah. So it's 102 that way, and it is that way. It's a little bit hard to tell this is a tapered channel because of the sketch, but that shows it a little bit better. Now the angle. So you guys have got a beam that you have to schedule for me, and you've also got a column which is exactly the same way of, that's just called UC, universal column. So there's pretty much two easy, well, won't be 2 marks, but there's a couple of half marks in the bank. Okay. Where it gets a little bit more tricky is the angle. We have an angle over here, 89 by 89 by 11. The actual modern way of calling it up is 89 by 11 EA, which is equal angle. My model answer has got 89 by 89. I've actually seen this on modern drawings that way around. I'll accept any answer, but that's my preferred one. If you don't want to accept it. It would be good if you. No, well you have an unequal angle, which is a UA. Oops, did I give you the answer then? Sorry. Yeah.
And then, would that not be when you want to put both?
Yes, that's when you put both dimensions. So it'll be 150 by 50 or whatever the EA is. In this case, we have an angle that is here and an angle that is there. There's two angles, right? But at the other end, and I'm only telling you this because it's not obvious, this here means that it's broken. The other end is another two of these and another plate. So let's call it 4. And the length of them we don't know yet because we have to calculate that. We'll do that in a minute. There's no width. What we are told at the top is that the angles have a weight of 14 kilograms per metre. Can you see that there on the last line? 14 kilograms per metre, so we can put 14 here. But we still don't know the length, so we're now going to calculate the length.
It says 11 on the drawing, eh?
On what drawing?
That drawing.
11.
Oh, the one you've got up here, the example.
On the example. On this here,
Yeah.
says 11. No, it says use 7850 kilograms per cubic metre for plate and 14 kilograms per metre for angles.
Okay.
Yep. So we use 14 for the angle, but we need to calculate how long the angle is. And here's the beam, and the angle sits between the beam. It sits in here. So we need to calculate that, and we know that the beam is 533 high, but we don't know what that distance is. Can anyone suggest where we get that from?
Thickness of the plate, maybe?
No, because it doesn't go down to the plate, it only goes down to there.
But then just double the thickness of the plate and take away from
Well, it's not actually a plate, it's the
the
flange here of the beam. Okay, if you look up there, we've got two. We've got a T equals, for the UB, the universal beam, we've got T equals 21.3 and T equals 12.8. Is it a big T or a little T? Is it big T or little T?
Big T.
That's big T, and big T is 21.8. 21.8.
3.
What? 0.3, is it? Right.
How do we know that it's a big T?
Well, because I told you.
That's not out the other end.
This is why you were here, eh?
what does UV stand for?
Universal beam. So 533 minus 21.3 minus 21.3 equals 490.4. But we don't do it, the surveyors do and put 490.4 there. We put 0.4904. So when we multiply that by that by that, just wait for the people in the back row to calculate it. Thank you. 27.46, is that right? Yep. 27 point, there's no one in the back row. 27.46. Yes, there is. Okay, you're going to have a problem in your assignment because you don't have, I'm not giving you how much your angle is per kilograms per metre, so you can't use 14. Students will use 14 because you're forgetting about this. You won't look back on the lecture like most of you didn't do for assignment 2. So what do? How can you work out your weight of your angles?
Check the volume and then multiply it
By
the density of
the
steel.
density of steel. Now the density of steel, I want you to use that as the density of steel.
7850.
Yeah, somewhere in the notes, someone put out that it was 7860, but please use 7850 for your assignment. Mass per metre, 7850. Use that on your assignment as well, okay? The thickness is 0.025, The call up for the plate is always the 250, which is the width, so it goes width by length. So 250 by the length, which is 0.350. Put that the wrong way around. I put the length first and the width second. It doesn't matter. Oh, no, that's correct. I have done it right. So when we call it up, it is 250 by 350 by 25. And then PL. And there are two of them. So that times that times that times that, even with that huge number there of 7850, it still only comes to 34.34. And of course it wouldn't be complete without a total, and the total of all our reinforcing for this job, don't forget to do a total. And some poor students are going to end up with that as their question, because I put a letter for the total as well, which isn't much fun. It means you're going to have to do the whole lot. 1123. Point, I think it's 8 more. Zoom in on that. It's not zooming. I think it's 80. Can someone check that? So it's these columns here.
You're saying there's no mass per meter for the angle?
No, there is now. So you've got to go into AutoCAD. I've provided an angle for you. Okay, don't do it off some chart that you've Googled on the internet, or you won't get that right. You need to list the P-line around it. You may have to explode it first. It might be a block. List the P-line. If it isn't a P-line, join them up. List them. You'll get a number. But that number's in millimeters squared. Then you multiply it by the length. If you have a look at the 3D model, you'll see that it's around about somewhere between 150 and 100 and 150. You need to read the drawing to find that. That'll give you one angle. Count the angles. Put it on the bar schedule. So it's the area times the length times the number times 7850 gives you a number here. 34 because that's what my site's telling me. Yeah, 34 by 34.
And that's from 2 times 0.35 times 0.35.
Oh, times this one as well, on the far right, the thickness.
Yeah.
So you've got 2 times 0.35 times 0.25 times 7850 times 0.025. There's always an R.
And why we?
Okay, that's it. That's the bar schedule. But at the last minute, the client has said to me, you know what? I want to know, will this angle stick out past here and cause me a problem? And I said, oh, don't worry, I can go back and calculate that using little t. So he's saying to me, will the angle go out past here on the beam? So what we need to do is calculate this distance here, which we'll call x. And so x equals, what's the width of that beam? 210. So it equals 210. minus the web, which is little Ted, 12.8, minus 12.8, divided by 2. And the answer equals 90, I think 96.8 or 98.6, I forgot. 98.6?
No,
Yes.
6.2.
98.6.
And then,
It is Thursday, not Friday.
97.
and then with that,
It is
89.
98.6, just like you said. So you've got the bragging rights now. That'll cost you have to buy her a coffee. Here we are, 98.6. And so therefore, if that's 98.6, our angle is 89 by 89. So that means that it will be back from the edge of the beam. Okay? And that number there, that 98.6, will go in here. It'll be 0.0986. It is not needed on your, sorry, on that 98.6 goes into the width up here, 0.0986. It's not needed on your schedule, it's just something that's on here.
Is it?
It's not needed as in your schedule because the client's not asking you that. I've just added that in to make it interesting. Okay, you can carry on with your assignment now. I'll finish talking for the week. So many things, so many places you could start. You could start with drawing up the plan view. I would suggest the schedule's also a good place to start because you get those numbers right, then they can roll over into your plan. Or you can just do the working out some of the quantities. The slab looks like this. What's wrong with just with working out some of the quantities for the slab? I'm sure if you were given that sketch at school and asked to work out the overall volume, you could do it pretty quickly. Here's an easy half mark to start with. There's also a lot of other things that you can do the quantities for as well. The only thing you can't really do at the moment is timber, although you can work out the lengths and you can work out the sizes, but you can't quite work out what to call it up as. We'll do that next week in our lecture. We'll talk about the tantalization process